Welcome, friends, to the series of learning containers and Kubernetes. So, in the earlier couple of lectures, we saw how we can install the Kubernetes on Ubuntu systems. So, we used AWS EC2 instances to launch the Kubernetes cluster. We installed the Docker and Kubernetes, and then we deployed the nodes. We deployed one node as master and one node as worker, and we set up the Kubernetes cluster. We followed the GitHub repository of Learning Light K8s, that is Kubernetes, and the instructions given there, we actually followed the same, and we set up the Kubernetes cluster. Now, if you have missed those videos, we are highly recommending you to watch those videos so that you can have a clear idea how we can install the Kubernetes on our on-premises or EC2 or virtual machine system. Now, today, in this particular lecture, we will actually deploy pods or containers through the deployments, and also we expose the services to the outside world. And we actually come to know what that the different kind of service exposure in Kubernetes like NordPorts, ClusterIP, and the load balancer. So as we are going to deploy the containers, we should know that the pods are the basic building block in Kubernetes. So the containers are running in pod, and pods are actually a collection of containers. Those are tightly coupled. In general, we actually keep only one container in a single pod so that we can have loosely coupled microservices and they can run independently without causing any issue within these couples. Now, as we are going to deploy the services in Kubernetes through deployment, we should know what exactly the deployment means in Kubernetes. So deployment in Kubernetes is a resource object that provides declarative updates to the applications. It manages the life cycle of applications, allowing for controlled transitions from one state to the another while ensuring the high availability and scaling of pods. So we can easily scale the number of pods in a matter of a second through this deployment. Now, these deployments offer the mechanisms for declarative updates. You describe the desired state of your application in a deployment object. Kubernetes automatically updates your cluster to this desired state. Deployments support rollback to earlier versions if a new update causes issue. So we actually can do the version controlling in Kubernetes through these deployments. You can scale your application up, down by adjusting the number of replicas. So it's a very easy peasy thing. You can just specify the number of replicas you want, and Kubernetes cluster is liable to provide that many replicas to scale your application accordingly. It is having the capability of self-healing. So Kubernetes ensured that the desired number of pods are always running. Rescheduling failed or unresponsive pods, if detected, then the self-healing process will automatically spin up a new pod and makes all them as healthy. Now, there are a couple of key features of deployments. Ensures the replica management. that a specified number of pod replicas are running at any given point of time. For the rolling updates, gradually replaces old version of pods with the new ones to avoid the downtime. We can have different versions of our services and we can easily deploy them. Easily we can update them with the matter of second without having any downtime. We can reverse to the previous deployment version if the current one is not stable. Allows user to declare the desired state of the application and Kubernetes will manage the rest. And the pod template specifies the configuration for the pods such as container images, labels, and environment variables. Now, today's demo, we will actually run the Kubernetes cluster on Google Cloud Platform. So this is our master and worker nodes, and we have created a couple of VMs on GCP Web Console, and we followed the same procedure to implement this Kubernetes cluster as we did in previous lecture on AWS system. Now here we are running this cluster on GCP. Now this master node is having one internal IP, and all these master and worker nodes are actually communicating via their internal IPs. So all the communications are within this Google Cloud Platform itself, and it is not being exposed to the external world. Now, if we go to this node, and we can see that currently all these nodes are ready. We are having one master node and two worker nodes over there, and all of them are Ubuntu 22.04 LTS version. And we are having the internal IP assigned to these nodes, and these internal IPs are actually the IPs of the machines provided by GCP. Now, we are having one app.yaml file, which is actually containing the deployment. We will actually run one Nginx service on our Kubernetes cluster, and this Nginx image will be pulled from the Docker Hub. So our deployment is basically having this name, Nginx deployment, and this Nginx deployment will have two replicas as we are specifying in this deployment template. Now, this Kubernetes cluster will be responsible to provide these two replicas all the time, no matter what. If one dies, it will automatically spin up the other pods in this particular cluster. And here is the specification. You can see the Nginx 1.16.1 image will be pulled from Docker Hub, and it will be running on 80 port, and 80 is the default port of Nginx. And if you see this Nginx Docker Hub description, it is also suggesting to run this container on port number 80. So once you are having this template ready, you can just say kubectl -f app.yaml. But before that, let us specify the internal CIDR range of master node and worker nodes. So let me cancel this command, and instead of doing that, let me patch our master nodes CIDR range to 10.244.0.0/24. So what it will do actually, whenever it will spin up the pods or the containers, it will assign a IP address to that particular pod. And this IP address, if that pod is going to be spinned up from the master node, then this particular pod will be assigned to a IP address which belongs to the CIDR range. So that is what we are going to say through this command. Now, similarly, we will assign another CIDR range for worker node 1, and similarly, we will assign a CIDR range to worker node 2 so that whenever a new CIDR range, whenever a new pod will be spinned up in worker 1, it will assign one of the IP address from this IP range. Now see, it is saying that the node and master node is patched, but there is no change. But in your case, probably you will not see these no change words because I already spinned up couple of containers over here, and we specified the same CIDR range on master node and worker node. Now we are going to say the same thing for worker node 2 as well. And this time we are going to provide the CIDR range of 10.224 244.2.0/24. And again, there is no change because we assigned the same CIDR range for all these three nodes. Now we are ready. We have assigned the CIDR range for each of the master and worker nodes. And now we can apply this app.yaml file on this kubectl command so that the deployment will be created. Now you can see the deployment is created. And how we can check the deployment? It's very easy. kubectl get pods. Okay. And you can see the pods are running. And one of the pods is actually crash back loop, but it will very soon will be in running state. What we will do, we will say watch -1 kubectl get pods -o wide. Now you can see both of these pods are running. Now, what we will do, we will actually scale these deployments from 2 nodes to 4 nodes. So 2 replicas to 4 replicas. So the command is very easy, kubectl scale, and we will specify the number of replicas we want. And we need to specify this deployment, and our deployment is Nginx deployment. So if we do so, we can see these replicas are actually scaled up, and you can see these actually spinned up across 3 nodes, and worker 2 also got 1 container, and master node got 1 container, and worker 1 got 2 containers. So this is how we can scale this deployment to any number. Now, we are going to expose this service to external world. Now, how we can do that? We can simply say kubectl expose deployment, Nginx deployment, which is the name of this deployment, and we are going to specify the port, which is port number 80, and we are going to give some name Nginx service. So if we do so, we can see kubectl get service. We can see there is a new kind of Nginx service has been exposed, but this time it has specified one cluster IP for this service. we can kernel to this particular cluster IP, and we can see this kernel is actually responding. So it is the default uh, Nginx welcome page, and that is what this particular machine can understand. If we go ahead and check the same thing from the worker node 1, all right. So this particular IP address can be reachable, and it is responding with the welcome to Nginx from both of these nodes. But the problem is that this particular welcome page can be accessible within this cluster, within this node cluster. So from master worker 1 and worker 2 can reach to this internal IP address, but this particular IP address is not accessible from the external world. So anybody outside this particular cluster cannot access this particular service. So what we will do, we will actually delete this service. So kubectl delete as we see, and we will specify the service name, which is Nginx service, and we are going to delete this Nginx service. And now we are going to say the same thing, kubectl expose deployment and deployment name and target port and port as 80. But this time we are going to specify type as NordPort. Now, NordPort actually exposes the services on each node's IP address at a static port. This means the service can be accessed from outside the cluster, and we are going to use the node IP and the node port. And this node port uses the ports from a specific ranges, typically from 30,000 to 32,767, which are reserved for these services. Node port is a more specialized service type compared to cluster IP. And when we are going to expose the service to external traffic, such as accessing the web application from the outside of the cluster, we can definitely use the node port. But the cluster IP, which is the default Kubernetes service type, it exposes the service to an internal IP address within the cluster. This means the service is only accessible from within the cluster and typically used for the internal communications between different services in the cluster. For example, we do not want to expose our application to the external world. We want to keep this confidential and secret within these internal network inside the cluster. Then we can use the cluster IP. Now, if we check this kubectl get service -4 wide, we can see the node port service is created and it has assigned to cluster IP, internal IP address, but along with that, it provides the port through which we can access this particular service from the external world. So if we go back to our Google Cloud Web Console, and if we grab one of the external IP address, and if we go to this browser and we specify the external IP address of any of the servers, and if we provide this port number, we can see our Nginx service is reachable from the external world. Similarly, if we grab one of the worker's external IP address, and if we specify this external IP address of the worker node, and if we give this particular port number 30660, we can see this Nginx is also accessible from the worker node as well. We can check the third worker node, and if we specify the same port over here, we can see the Nginx is actually servicing by any of these three nodes, all of these three nodes. So that's exciting and excellent. So this is how we can run the deployment in Kubernetes cluster, and we can expose the service to the external world, or we can keep the service confined within this cluster itself, within this Kubernetes cluster itself. Now, there is a third kind of Kubernetes service, which is called load balancer. And if we specify this load balancer, if we check this particular get service command for this NordPort or the cluster IP, we can see the cluster IP is defined, but there is no external IP assigned for these kinds of services. But if we specify the load balancer kind of service, we can see the external IP address is also defined. So thank you for watching this video, friends. So in this particular lecture, we have deployed the application inside the Kubernetes cluster, and we expose the service internally and as well as externally to access the services, and we saw how we can easily scale those applications within a blink of an eye, and this is very much easy. And Kubernetes is also responsible to have the horizontal pod auto scaling, which will automatically scale in and out depending upon the workload, and how we can specify the matrices so that the horizontal pod autoscaler can scale our workload accordingly. So all these exciting things we will be seeing in upcoming videos. Till then, goodbye and be safe. Thank you.